All right. Hey guys, me again. On to 11.2. Um, Again, this one is more about building background on statistical studies, and we're talking about sampling methods. So it's more about learning the vocabulary and the different ideas and concepts that go with it, not so much calculations yet, but we will get there. So we're going to start with talking about different types of studies, right? So once you have your statistical question, you have to figure out which type of study am I going to conduct. There's three types that we're going to talk about: a sample survey, an experiment, and an observational study. Um, so a sample survey, when you hear the word survey, it makes you think about, right, I'm getting a paper with all these questions on it. That's exactly what a sample survey is. You are going to ask every member of a sample the same set of questions, and you're going to record their answers. So the example they give us is a newspaper poll randomly selects residents in a town about which mayoral candidate they prefer. So they're going to send this survey to a random sample and ask them to tell them which person do you think should be mayor next. Okay, everyone gets the same questionnaire. You could also design an experiment, right? So I want to go back to that first one. A sample survey can be really useful for categorical variables, right? So asking which mayoral candidate do you prefer, which sport do you prefer, things like that. An experiment might be more helpful for quantitative variables, right? So an experiment is exactly what you think about it, like a science experiment. You're going to apply a treatment to one group and not to another. So the example they give here is about clinical trials and blood pressure. Again, the real world example of this happening in our life right now is coronavirus vaccines, like I talked about before. So when those scientists conducted their study, they had two groups: one group that received the vaccine and another group that received a placebo, right, or didn't receive the vaccine, and tested the effectiveness, comparing the group that got the vaccine to the group that didn't. That was their experiment. And then the last type of study is an observational study. And the key word there is observing, observational. You're just observing things. You are not imposing anything on anyone, right? So the example here, a grocery store wonders how many customers bring reusable grocery bags to the store. They have an employee stand at the checkout counter and count the number of people using bags. They're just observing and recording the data, not asking or doing anything to any of the participants. So when you're choosing your question, then you're going to go through and think, what kind of study makes sense to answer my question? And then after you choose your study method, you have to start thinking about how you're going to get your sample, right? Because one of the most important things is that your sample is a reliable sample and doesn't have any bias. So bias means that your results, that your sample is going to impact the results. It's going to misrepresent the population. So for example, there's this question here about a psychologist. They're conducting a survey to see the happiness of levels of people who live in a neighborhood. So she asked the same questions to the two samples below, chosen from the population of the neighborhood. So she is doing a sample survey. She has her question. She's going to ask everyone the same question. So she goes out on a sunny Saturday afternoon, interviews 100 people, and 65% of them say they're happy in this neighborhood. Then she goes back out on Monday. She surveys another 100 people, and they're all crowded on their way to go to work, right? Monday morning, really not everyone's best time of the week, and only 35% of the people are happy, right? So you would say that if these are two different neighborhoods that you're interviewing, there's definitely some bias there. These people that were interviewed on a sunny Saturday afternoon are going to feel more happy than these other ones on the way to work. So you would want to make sure, if you're comparing two neighborhoods, that all of those variables are the same. You can also talk about bias. This little thing over here that I added can also arise if you're only including a certain category of the population. So if I'm going around and asking people how happy they are, but I'm asking them outside of, as they exit LaBim Mall or something, right? Those are going to be a different category of people than if I walk around and ask people if they're happy. I don't know, the people who are walking along Ring Road, right? You have to make sure that you are including all types of people in your sample survey so that your results are not biased. You're not misrepresenting the population. So how can you do that? How can you eliminate bias from your samples? Well, the simplest way is to use a simple random sample, right? In a simple random sample, each member of the population is equally likely to be chosen, right? So if you are a person who makes less than $10,000 a year versus you're a person who makes over $1 million a year, you're both equally represented in my sample, for example, if economics is an important factor. And there's different ways, different types of sampling that fall in that category. So these first three, stratified, cluster, and systemic, are ways where you can try to, that are more easily adapted to avoid bias. And then you have these two at the bottom, which are sampling methods, but there's a high risk of bias. So let's talk about them. So these are the definitions down here in this table, and you can see them on page 560 of your book. And then on the side, I have examples of them. So we're going to talk through them all. So stratified sampling is when you divide the population into like groups and then take a random sample from each of those groups. So an example of that would be vaccine trials. So you include random participants across all age ranges from the 6 continents. So your groups were broken up into which continent you lived on. So now I have these 6 groups. And then from those 6 groups, I'm going to randomly pull 1,000 people of all varying age ranges to give the vaccine to. Okay, so I broke them up into groups, and then I made sure that I had a random sample from each one of those groups. The other type is cluster sampling. So now your population, instead of being broken up into groups that have a similarity, they're really just broken up into groups, or what we call clusters, that are convenient. And then you choose the entire clusters at random. So for example, in this one, in Germany, they want to test cell phone reception. So convenient cluster is to just take major cities. So now I have all these major cities across Germany, right? And now this part's missing from here. So when I'm going to go just choose 6 cities at random, I choose those 6 cities and I study the people who have a cell phone. Right? So my clusters are broken up into things that are convenient, and then I choose from those clusters. That if I were to take cluster sampling and apply it to this first example, right? So I'd have my groups broken up by continent, and then I would just choose 2 continents, Asia and Africa. And those are the only continents I'm going to test. But then I would have to test everybody in those 2 continents, right? So that's the difference between cluster and stratified. And then systematic sampling. It's based more on like a numeric thing. So it's when you choose one person. So let's say I was doing this in class. I could choose the 3rd seat, and then I would say, okay, everyone else count off by 3s, and everyone who has a 3 is who's going to be in my sample. And so the example I gave here is like every 5th student ID number is chosen, and then you're asked to fill out a survey. Okay, now the last 2 are there's a high risk of bias, right? Because you're really narrowing your sample to only be represented by a certain number of people. So convenient sampling is when you choose subjects that are in close proximity or easy to get to. So in the States, that would be like going door to door and asking people a question, right? You're really, unless you're sending people to every neighborhood, if you're just going to 1 or 2 neighborhoods and going door to door, you're really limiting your sample because you're only representing certain neighborhoods. And then self-selected sampling is when you only include people that want to be included, almost like they're volunteering. So a store puts a survey in the shopping bag of customers and asks for their feedback. So only the people who feel like it are going to fill in that survey and mail it back. You're not really getting a true sample, right? Because you can think about that. Who generally fills out forms or gives feedbacks? People that are really happy or people that are really upset? You're really missing out that middle chunk. Okay, so I want to give you two examples. I want you to take a second and think, which type of sampling method is this? The population is grouped according to age, and a random sample is chosen from each group. Take a second and go back. What type of sampling method is that? Or B, a number of hospitals around the country were randomly chosen. Within each hospital, all of the nurses were chosen. So the A is stratified, right? Stratified because you're dividing everyone into like groups according to age, and then you're choosing a random sample from each group. B is cluster because we're dividing these people into convenient clusters, hospitals. And then within the hospital, we're saying, okay, now we're going to talk to all the nurses. All right, now we're going to move on to experiments. So talking specifically about experiments for your study. So I think you guys probably already know this just from science, right? If you're conducting an experiment, you have to have two groups, an experimental group and a control group. In our vaccine example, it's these people get the vaccine, these people don't, and we're going to find the differences. This is an example, similar example with mice. You can read it if you would like. It's on page 561, or you can pause and read it here. That is it for lesson 11-2. I will see you guys next time.